Okay, we are going to continue our discussion about the running time and the big O's. Well, this is a new Jupyter notebook, and then in this one, I want to talk more about if we do have a understanding on what kind of algorithm it is, and then how do we estimate the running time. And that's important because, say, well, you only run 1% of the dataset, and then it runs for 5 hours, for example. And then your next question will be, do you want to run the same algorithm again on 100% of the dataset? Well, why? Because, well, if it is linear and then that is 5 times 100, that is already 500 hours. Well, probably it's not that good. But if it is a cubic or a quadratic algorithm, and that is really not doable. So based on usually when you run a algorithm, you want to run the algorithm on a fairly small data set just to make sure that, well, this algorithm works, and then you can evaluate the early results. And eventually you want to decide, is this really doable for you to run the whole data set using the same machine learning model. And in some cases, it's not even possible. Okay, so this is the point we want to discuss. How do we estimate the running time of a dataset based on a subset of the data already run on that algorithm? Okay, so let's see if the algorithm is linear, and then, well, it's kind of easy because we double the dataset and then we double the running time. And then how about quadratic? How about cubic? How about n log n, which is log linear? Okay, so, well, let's do a very hypothetical case. Suppose that it takes 100 milliseconds to process 1,000 items. Okay, and then this 1,000 item is just a subset of the full data set, and then we have 10 times, so 10,000 items. And then how long it will take to process 10,000 items? So if we assume that is linear, and then a linear means, well, we do 100 milliseconds, and then we are able to process 1,000 items. And we can just assume that for those 1,000 items, and they require 1,000 primitive steps. So that is 100 milliseconds. We are able to process 1,000 primitive steps. And then we want to get the t for the 10,000 items or 10,000 primitive steps. And then we got 1,000. That is the 10. If we have 10 times of the dataset, and then we have to put 10 times of the original running time. So not so bad, right? And how about quadratic? For the quadratic, well, we process 1,000 items, but remember that is quadratic algorithm. So this means that is 1,000 square primitive steps. Okay, now we have 10,000 items, and then it will be 10,000 square primitive steps. And then again, we want to get the t, and then this t will be 10,000. So that is 100 times longer. And then how about cubic? So for the cubic, it means that, well, we have 100 milliseconds, and then we are able to process 1,000 cube primitive steps. And then we want to have the t so that we can process 10,000 cube primitive steps, and then we have 100,000, and that is 1,000 times longer to process only 10 times more of the dataset. So that sounds terrible, right? So by the way, what is a cubic algorithm? Remember, in the very beginning, we talked about an algorithm called dbScan, and that is a cubic algorithm. You do have to be very careful, because if you have 10 times more of the data, you have to put in 1,000 times of the running time. That's scary, right? And how about log linear? So for log linear, and then 1,000 items, it means 1,000 multiplied by log 1,000 primitive steps, and then we plug in the 10,000 here, and then we got 1,300 something. So that is if we have 10 times more of the dataset, and then we only need to put in 13 times more of the running time. So, well, it is a little bit worse than linear, but not so bad, right? Okay, so, well, those are one scenario. And another scenario will be, well, suppose that you have for again 100 milliseconds and you can process 1000 items, and then how many items can you process if you have 400 milliseconds? Okay, and then again and do the calculations here for linear, quadratic, log linear, and well, eventually log linear, and then eventually no, I didn't do qubit. Okay, so and then just finish those ones, and you just need to do the calculation similar as what we have done just now. And if you are able to get that, and then we are finished today's lecture. Okay, so pause the video here and then try to do some math on those boxes. And especially for this one, you are going to need a online calculator to figure out the n log n. Okay, so pause the video here. Okay, so I will show you what I did. So 100 milliseconds, and then we can do 1000 primitive steps if it is a linear algorithm, and then if we have 400 milliseconds, and then how many primitive steps are we able to do, and then we are able to do 4000 primitive steps, and that also means that is 4000 items. So well, that is for a linear algorithm. And then for the quadratic, and then 100 milliseconds, and then we can do 1000 square, and then 400 milliseconds, and then x square, and then x will be 2000. So this means we have 4 times of the original running time, but we can only do twice as much of the data. Okay, and then how about log linear? And then for the log linear, and then that will be x 100 and divided by 1000 log 1000, and then 400 divided by x log x, and then you have to figure out this. You can first I figure out the x log x, and then using that x log x, and then I figure out the x, and then this x is 1600 something. Okay, so those are two ways that two possible scenarios that you may do if you want to if you have a machine learning model, and then you run that on a small portion of the data, and after that you can do a estimate on how long do you want to put in the time, and then based on the time, how much data are you able to run on that machine learning model. And well, especially in the next semester, when you are doing more machine learning models, and sometimes you run data on some machine learning model, but usually you started from a small portion, like 1% or 0.1% of the data, and after that you can estimate if that model is really doable on your machine, and can you really afford the running time. Okay, so that's it for today, and I will talk to you tomorrow. Bye.